first virus hunter in space to test DNA sequencing device at the ISS. NASA astronaut Kate Rubins, who arrived at the International Space Station ISS earlier this month, was trained as a professional virus hunter. She has conducted research on Ebola, smallpox and other deadly viruses on Earth before becoming the 60th woman to fly to the orbiting laboratory. She may currently be stationed at the ISS, but this won't stop Rubins from conducting DNA research, as she is set to become the first virus hunter in space who will attempt to conduct the first full-blown DNA sequencing in orbit. Rubins will use the DNA sequencer, a pocket-sized device that reveals the order of chemical building blocks along a DNA strand. The device is to be brought to the ISS by the latest SpaceX cargo delivery, which is set for launch from Cape Canaveral early Monday morning. Rubins' work at the ISS will involve harmless test samples, a virus, bacteria and a mouse genome. Researchers initially wanted to use extreme and bizarre samples for the space experiments, but they eventually settled to well-sequenced and well-understood genome to make comparisons easy, said Sarah Wallace, from NASA's Johnson Space Center. The device may shed light on the nature of a mysterious fungus that currently grows on the inside of a door on the space station. Wallace said that knowing whether the fungus is benign or something that should raise concern could help microbiologists determine what to do to deal with it. Scientists also hope that the device, which is about half the size of a smartphone, will help identify DNA-based life on other planets, albeit this may involve further developments to become a reality. The MinION sequencer may also prove whether or not the technology can be used to scan astronauts for genetic changes that may help diagnose illnesses. Scientists also want to know how the device will work in microgravity, since technology behaves different in space. Oxford Nanopore Technologies, which is behind the experiment, said the device that Rubins will use in space is the same model that is already used by more than 1,000 scientists in 30 countries. Wallace, however, said that unlike most sequences wherein samples are run for 24 to 48 hours, the sequencer at the station displays the analysis as it works. Within minutes of loading your sample, you're starting to get the sequence data back.